Chapter 17: Water Use and Management. Water is essential for life. It is the availability of liquid water that sets the Earth apart from other known planets. This chapter discusses water as a resource and what we can do to protect it. The energy of the sun is the power that drives the hydraulic water cycle. The sun striking the oceans cause water to evaporate and rise into the atmosphere. This water is transported to areas over land where it condenses and falls as rain. This rainfall is either absorbed by the ground to become groundwater, or it collects and flows across the surface as river, lakes, and streams. This surface and groundwater flows downhill, where it eventually returns to the ocean. Additionally, plants pull water from the ground and release it to the atmosphere in a process called evapotranspiration. A map of average annual precipitation. Water is not evenly distributed across the Earth's surface. This occurs for many reasons. As you recall in our discussion about the atmosphere and biomes, areas of the Earth where high pressure systems dominate are characterized by very little rainfall, deserts. Conversely, areas where low pressure dominates, the tropics, there is a lot of rain. Other factors that affect water distribution are how close an area is to water and topography. For example, the central portion of the U.S. is dry because of its distance from any major water source. When large topographic features occur on land, they affect wind circulation and uplift of the air. The Rocky Mountains separate the western U.S. from the east. The prevailing wind direction, and therefore the direction of major weather patterns, is from west to east. These are called westerly winds. As the westerly winds move from California toward the Rockies, the air is lifted as it moves up the slope. As this air rises up the mountains, it cools, which causes water to condense. This causes heavy precipitation on the west or windward side of the mountains. As the air continues east and crosses the Continental Divide, it begins to descend on the east slope of the Rockies, the leeward side. As it descends, it warms, which dries the air out. The end result is the windward side of the mountain received more precipitation than the leeward side. This effect is called a rain shadow. An illustration of the rain shadow effect. Major water compartments. The distribution of water across the Earth is often described as interacting water compartments. Water may reside briefly in one compartment or stay there for eons. The length of time water typically spends in a compartment is called the residence time. For example, the average residence time of water in the ocean is about 3,000 years before the water evaporates and enters the hydraulic cycle. When we discuss nutrient cycles, including water, we usually discuss them in terms of sources and sinks. These sources and sinks are the major compartments of water. Of these, the ocean is the largest and functions as both a source and a sink. A map of global ocean currents. Water can exist in three phases: liquid, solid, and gas. Solid water is ice. Most ice on Earth occurs as either snow, glaciers, or ice. Of these, ice and glaciers are the largest components of solid water. One interesting fact is that of all of the glaciers, snow and ice are fresh water. In some areas, this can be a significant source of fresh water. As we mentioned earlier, precipitation falling on the surface either runs off to form streams or it is absorbed into the ground. This groundwater is the second largest source of fresh water on Earth. As this water moves into the ground, it eventually fills all of the available spaces between the soil particles. This saturated soil is called the zone of saturation. The area where both air and water occur is called the zone of aeration. The boundary between the two is called the water table. The water table is not always below the surface. Sometimes it can reach the surface. When this happens, a spring or artesian well forms. An illustration of infiltration. Because of the amount of land, freshwater aquifers can be very large. The Ogallala Aquifer occurs in the central U.S. and is found in parts of 8 states. These aquifers are often used extensively for irrigation and agriculture. Regardless of the location, the aquifers are recharged, as is all groundwater, by precipitation. One thing to keep in mind is that the area where this recharge occurs may not be near the actual aquifer. These recharge zones can often be miles away from the aquifer location. An illustration of the groundwater system. Rivers and streams occur when excess water that cannot filter into the ground collects and runs off. The amount of water collected and transported by rivers is known as the discharge rate. This rate varies by location due to soil type, topography, and precipitation. Table 17.3, Major Rivers of the World. The smallest water compartment is the atmosphere. This isn't because of lack of water. Remember, all water in the ground and in streams and rivers come from precipitation. This reservoir is the smallest because it has the fastest turnover rate. In other words, the water in the atmosphere is quickly moved from oceans to land by precipitation. Water is considered a renewable resource. Because of precipitation, water is constantly renewed. However, as we will see later, water can become non-renewable for various reasons, to include overutilization, withdrawal, and pollution. Remember, in the context of resources, it is their availability to humans that matter. Other factors that affect water availability besides overuse include droughts. Even in areas where water is usually plentiful, short-term changes in weather patterns, do you remember Enzo, can cause short-term changes in availability. During some periods, an area may receive floods, which provide short-term increases in water, but don't necessarily provide long-term benefits because most of the water runs off. Conversely, areas can have periods of drought where the amount of precipitation does not adequately replenish supplies. These droughts are especially problematic in less developed countries and often lead to famine. Water use is measured by withdrawal and consumption. Not all water drawn is consumed. For example, water drawn for irrigation may not actually reach the plants it was intended to reach. Some of the water may be consumed by evaporation and not uptake by the plants. Water is used in many ways by humans. The largest consumer of water by far is agriculture. Ag practices account for 70% of the water withdrawn and 85% of the water that is consumed globally. While agriculture is the consumer and in the end the consumption is a result of the food consumption by consumers. Of the water withdrawn, the majority, 70%, is for irrigation. Current irrigation practices are extremely inefficient, with most of the water withdrawn is lost to evaporation. Additionally, irrigation not only withdraws water from the ground, but also salts and minerals. Over time, irrigation using groundwater will cause the soil to become salty. It can also cause heavy metal contamination. Other methods exist, but they're expensive, so most large ag industries prefer not to use them. Surprisingly enough, direct withdrawal and consumption for domestic use is very small. Even industrial use is way less than agricultural uses, although it can be high locally. You need to keep in mind, though, that industry is driven by demand. As with agriculture, you are indirectly responsible for the water used in an industry. A pie chart showing the typical household water use in the U.S. At current rates of use, the recharge rate for groundwater in many areas is exceeded by withdrawal. This heavy pumping of aquifers leads to lowering of the water table, subsidence of the Earth's surface as water is removed from the spaces between soil, and contamination of wells. We are living on borrowed time at current rates of withdrawal. A map of the Ogallala Aquifer. The Ogallala Aquifer underlies 8 states between Texas and North Dakota. Heavy pumping has dried up wells and whole towns are being abandoned. It will take thousands of years to refill. Depleting groundwater. Withdrawing large amounts of groundwater in a small area causes porous formations to collapse, resulting in subsidence, settling. Saltwater intrusion can occur along coastlines where overuse of fresh water reservoirs draws the water table low enough to allow saltwater to intrude. An illustration of saltwater intrusion. What can we do individually to conserve water? While domestic use is small, changes in our habits can make a difference locally. Additionally, because of the large impacts on water by industry and agriculture, we can make even larger differences by making changes in our consumerism and by choosing food grown using more sustainable irrigation practices.